Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss about that impact of forest fires on Google Earth Engine platform, how we can easily monitor the impact of forest fires, mainly air quality mapping and monitoring in Google Earth Engine platform. Okay, so I will try to discuss all of those things step by step and also show you that all of those algorithm and also show you that practice code. So how we can easily assessment of forest fires on air quality mapping and monitoring in Google Earth Engine platform. Okay, so let's go. First of all, overall methodology is that in this time we are using here the Google Earth Engine platform, and mainly we can easily get the burn area using the different types of ratio or spectral indices such as NBR, normalized burn ratio. Okay, and for the air quality monitoring, we are using here the Sentinel-5 satellite imagery and get the nitrogen dioxide and carbon monoxide. And also for the temperature, we are get the data from the MODIS land surface temperature data. And also you're using here the rainfall data. These data set we can easily get from the charts data set. Okay, so let's go about that, all of those things step by step. First of all, spectral indices. So mainly the fire spectral indices determines the age of burning areas by normalized of burn ratio. It's called normalized burn ratio or NBR. So basically, this is the formula about that normalized burn ratio. Near infrared subtract with short wave infrared divided by near infrared plus short wave infrared. But when you want to calculate it, the difference of the normalized burn ratio, for that your equation is that normalized burn ratio NBR pre subtract with normalized burn ratio post. Okay, so when you want to calculate it, the biotemporal difference of the NBR, just simply subtract the NBR pre subtract with NBR post. So in this time, rainfall and temperature data. So mainly the rainfall and temperature data, we can call it from the charts, as well as also for the LST monitoring, we can get use here the MODIS LST dataset. And pollution monitoring, we are mainly using here the nitrogen dioxide and carbon monoxide dataset of Sentinel-5 satellite imagery. And the primary source of carbon monoxide and nitrogen dioxide, mainly it is the combustion of fossil fuels, biomass burning in the atmosphere, and the natural process, wildfire, lightning, and microbiological mechanism in soil. And mainly tropomy give the Sentinel-5 satellite imagery, measures the carbon monoxide global abundance using the clear sky and cloud sky, Earth's radiation parameter in that 2.3 micrometer short wave infrared components of the solar spectrum. Okay, and in this time, this is the reference paper link. This paper I follow and then try to develop the code. So let's go about that. We simply go to this code editor and try to discuss about that. So first of all, I try to show you all of those layer which I add in here. So first of all, here I add the two time period, mainly before forest fire and after forest fire. So in this time, this image showing about the before forest fire. And also you can see another image is that after forest fire. Okay, so this is the condition about the after forest fire. And this condition in this time, it's showing the condition about that before forest fire. So I can take the satellite image. If you want, you can use here the Landsat OLI sensor, or if you want you can also use here the sentinel. There is no problem. But our equation is the same. It is that near infrared minus short wave infrared divided by near infrared plus short wave infrared. Okay, so here I can get the before. This is the before situation for this forest fire, and this is the after situation. Okay, so here I can get to the difference. You can see when I get the after forest fire, I can get the image look like that. Loss of forest will be lost. You can see in here. Okay, as well as you can see pre-fire NBR. So mainly this it identify the pre-fire event of normalized burn ratio, and also post-fire normalized burn ratio. You can check about the result. You can see it's identify the normalized burn ratio after post-fire. Okay, you can see the change mainly it is the DNBR. Mainly it is the difference between the pre and post. Okay, I can get the change look like that. Okay, so in this time I can get the change look like that. I can easily identify this is the burn area. We can get the burn area. You can see the burn area. Okay, so finally we can also make the class about the severity mapping, burn severity mapping, and using this class we can easily identify the unburned area, low severity, moderate low, moderate high, and high. So here you can see easily find out all of those things in here. You can see, so basically it's showing the burn severity mapping, and we are also classified about the different classes. So unburned area, low severity area, moderate low, moderate high, and high severity region for this forest. So it will be loaded. You can see just I simply show the severity mapping. So here you can see this is severity mapping. Mainly in this time, this green color it is the unburned area. Okay, and yellow color identify about the low severity, and this type of color identify the moderate low, and red is the moderate high, and this color is identify the high severity mapping of forest fire. So mainly this is the high severity forest fire region you can find out. Okay, so in this time we are also make the analysis for the air quality parameters and identify what is the condition about the two time period, post fire and pre fire, and impact. We can mainly use the time series chart and check about the result. Okay, so here I already write the code in here and find out the you can see mainly this chart is for that mainly carbon monoxide time series chart post fire. So after fire condition, what's the condition about the carbon monoxide? You can get the chart look like that, and we can get all time the chart is the high. You can see we can get the high produce of carbon monoxide after post fire event, as well as if you want to check about that um, pre-event about the carbon monoxide, then we can get the chart look like that. So it's not the high situation. Okay, but when after completing the post fire, or after if complete the event of the post fire, we can get the high situation about that. Okay, you can see high all time we can get the high situation. You can see high situation about that carbon monoxide density 0.6 mole per meter. Okay, for this region. Okay, so this is the process for making the carbon monoxide or nitrogen dioxide or sulfur dioxide, any types of gases you can easily compare with the forest fire region. Okay, so mainly when burn the different types of fossil fuel or trees, it will be produce the different types of gases. So that's why in this time we can get the carbon monoxide concentration is the high on the post fire event. Okay, for this region. Okay, so mainly in this time here I use the code about, you can see we are using here the Sentinel-5 for the get the data from that carbon monoxide or nitrogen dioxide or sulfur dioxide or air quality parameters, and mainly this ratio we are just calculating the ratio using that Sentinel 2 satellite imagery we are using here. So this is our before means that pre, and after means that post. Okay, we can get the two event about that, and then we can simply just show the result about using the equation near infrared band, and also put here the short wave infrared band. Okay, and also make this equation and calculated the normalized difference burn ratio. Okay, after that we can simply calculate it the change mainly it will be difference between the NBR post and pre. Okay, after that we can calculate the severity map and find out where is that high severity, where the unburned area, low severity, moderate and moderate high. Okay, so this is the process for making the burn severity mapping and also make the uh, impact of the air quality. What is the condition about the air quality after the forest fire? We can easily identify about that. Okay, so if you want to learn the more details about that, you can simply go to this paper link. Okay, basically in this paper link you can get all of those things about that. Okay, so in this time you can see this is the code about that. We can easily develop the code for that severity mapping and also impact of air quality monitoring for the forest region or forest fire region using the Sentinel-5, as well as we can also use here the Lancet and also find out the when the forest fire, what is the condition about the land surface temperature and also precipitation. Okay, so this type of analysis I also try to show you the next further class. Okay, so today is no more. If you want to like the video, then simply comment on your and comment and also like about that. So if you want, you can join my online training programs such as live training online training program for the Google Earth Engine or deep learning or machine learning. Just you can simply contact with me. I will give you all of the information in the video description so that you can easily join. And currently, our this registration is the open for the 7 days of complete online training program on Google Earth Engine for remote sensing analysis. And this class will be start from the 8th September, and admission last is the 5th September, and booking last is the 8th September. Okay, and in this time we provide the 10 people. For the first 10 registered people get the 50% discount. Okay, and total class 7, and Friday and Saturday in a week we can take the live training class, and class duration is a 3 hours each day. It will be start from the 9 p.m. to 12 a.m. GMT plus 6. Total 3 hours online training program one day. Each day we provided 3 hours, and language mode is the English. And for booking your seat, simply contact with this WhatsApp number or contact with this email. So in this online training program, it's mainly for the beginners who don't have any knowledge about the Google Earth Engine platform, who don't have any knowledge about the JavaScript programming, who don't have any knowledge about the Python. So then this course is only for you as a beginners who don't have any knowledge. In this online training program, I will try to show you all of those necessary things to start the Google Earth Engine platform for remote sensing analysis. And we mainly covered the land use, land cover classification, air quality monitoring, time series analysis, different types of supervised and unsupervised machine learning method. So a lot of things we try to complete it in here. So if you are beginners or if you have done no knowledge about that Google Earth Engine or JavaScript programming or Python programming, this course is for you. In this online training program, you can easily learn all of those things and then apply this knowledge in your research work. So mainly here you can find out a lot of this course content. So here you can see the introduction, JavaScript programming language A to Z. We try to complete as a beginners who don't have any JavaScript programming. So there is a no worry about that. And we also try to discuss about the Google Earth Engine server language A to Z. So all of those things we try to complete it in here. Total 26 course content. I add all of those course content in the video description so you can easily check it. And you can also get the some benefit is that course e-certificate and also get the material, then slide, PDF, all of practice code you can easily get, and get the recorded video class. If you miss any class, then you can easily cover using the recorded video class, and you can get the lifetime teaching support. Okay, so using the Google Earth Engine or remote sensing, when you face any problem, you can get the freely lifetime teaching support from here. Okay, so if you want to join this online training program, then simply contact with this WhatsApp number or contact with this email and confirm your registration and join in our Google Classroom. Okay, so today is no more. Hope this video is you like and also learn from here. So if you have any question or any doubt, just comment on the video description. Then I hope you can really answer all of those questions in the comment section. Okay, so today is no more. Stay happy and stay safe.